Hello students, this video is about ISI Indian Statistical Institute 2017 question solution for the Bstat and Bmath entrance. I will start with the subjective. You must have seen my other objective answers. Here I will start this video with a subjective answer. First let me write the question. Let the sequence, they have given a sequence, let the sequence AN where n is greater than equal to 1 is defined by an equal to tan n theta. Okay, so simple trigonometric function where tan theta equal to 2 given. Show that, after that they have written, show that for all n, an is a rational number which can be written with an odd denominator, which can be written with an odd denominator. So, how to solve this question? In order to solve this question of an, let me just rewrite the structure. An equal to tan of n theta. So, it can be tan theta, it can be tan 2 theta, in that way. Maybe any value of n goes to infinity. So, as n greater than equal to 1, so at n equal to 1, this is tan theta equal to an. That's it. So, and tan theta equal to 2 directly given. So, we can write a1 is 2, a rational number. So, assuming this, so we can write n equal to p. Let n equal to p, and that is the, suppose that n p theta equal to, with respect to a basic structural formation, k by 2t plus 1, k by 2t plus 1. Then it's a rational number with an odd denominator, very basic structure, t equal to any number, 1, 2, 3, dot, 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 n. So 2t plus 1 is odd. Okay, when this value, when p equal to 1. Now for n equal to, for n equal to p plus 1, n equal to p plus 1, for example tan p plus 1 of theta, we can write tan of p theta plus theta, then you know the formula, that is tan p theta plus tan theta, 1 minus tan p theta into tan theta. So in this structure all we have to do is to put the values, that is k by 2t plus 1 plus 2 and 1 minus 2 into 2t plus 1. So p plus 4t plus 2, and the denominator will be, okay, k plus 4t by 2 and 1 plus 2t minus 2k, this thing. So finally we can write k plus 4t plus 2, 1 plus, take this thing common. Okay, since now we can see that here t is an integer, k is also an integer. So hence the ratio we found is a rational ratio, hence The ratio is rational. So with respect to a denominator, we can say hence the denominator one plus 2 t minus k is odd. Proved. So this is the first question done. Now we can proceed to question number 2. Question number 2 was relatively difficult. In question number 2 they have given, consider a circle of radius. They given a circle of r equal to 6 as a radius given. And they are actually given a diagram here. In general, as I don't draw the diagram, but this time they have given it. A D E. Circle, and then let BCDE be the points on the circle such that BD and CE when extended, BD and CE when extended intersects at A. Okay, if AD and D have the length AD equal to, so here AD is 5, AE is 4 given, and DBC is a right angle triangle. Okay, 90 degree. This is 90 actually. Then they have asked you to find the simple value of BC. Actually, asked you to show this thing. So proof is always safer, I believe. Let's solve it. Here, in this particular question, we have to, this is a structure called point powers. Point power is a structure, or power of a point is a structure, very basic in geometry. Now, what is the power of this kind of structure? Let me explain this to you. What is this concept is all about? Concept. For example, in basic geometry, it's a real number. For example, h, a real number h that reflects the relative distance of a given point from a given circle. So relative distance of a point from a circle. So it's not the distance, it's the relative distance. Okay. For example, if I draw one circle like this, and this is like this is B, this is A, T, this is P, this is N, this is M. Okay, if something like this happens, where O is the circle's center and R is the radius, then we can write H equal to A square minus R square. S is the distance between P, S equal to the distance between P, that is this point, and the center O of the circle. So S equal to OP. By this definition, and R equal to the radius, and H is the relative distance or the real number which we are talking about. The power of a point is as the point circle power, or the power of a circle with respect to a point is known. So how I find it out, if you ask me, then we can immediately write that Pt square equal to Pm into Pn, that is Pa into Pb as well. So S minus R into S plus R. So that is S square minus R square, and this is simply h. So this is the way to find it. So now coming back to our question, here let point B equal to 0, 0, C equal to x comma 0 and point D equal to 0 comma y. As AD equal to 5, therefore the coordinate A equal to 0, 5 stops y. So using the power property which we have written upside, so we can write AD into AB equal to AE into AC. So this is very important. As A equal to 4 units, so we can write 5 into 5 plus y equal to 4 into root over x square. And the formula of triangles, this thing. So ultimately this will, we can hold both sides square, so this will come down to 5 plus y is 16x square. Now x, y are positive, so we can take the square root of both sides, so we can write 3 into 5 plus y equal to 4x. So y equal to minus 5 plus 4x divided by 3. Now angle DBC is 90 degree. This is very important. So DC equal to diameter. DC equal to 12, as radius equal to 6, so DC must be 12, so we can write x square plus y square equal to 12 square. Now in this equation we can change the structure and we can write x square 4x by 3 minus 5 whole square equal to 12 square. So now everything here is with respect to x, so it will be 25x square minus 120x minus 1071 equal to 0. So as is here we can solve it. 120 plus minus root over 120 square plus 107100 whole divided by 50. Or x equal to, can take it common, 10, so 12 plus minus 10 root 1215 by 50, 15 by 5, proved. Hence the distance is this. Okay. Now we can proceed to the next question, that is question number 3. So in question number 3, what they have given, let me just write it for you. Suppose the number given by a function fx equal to, let's put a bigger function here, 1. If x equal to 1 and this thing is e to the power x to the power 10 minus 1 plus x minus 1 whole square sine of 1 by x minus 1 when x not equal to 1. So this is applicable for both parts. So first question is find f dash 1, question 2 is evaluate limit x tends to infinity 100 u minus u summation of k equal to 1 to 100 f of 1 plus k by u. This one is the question. So second one is a little bit challenging. We'll start with the first one. Let's see what happens. First of all, y just need to check whether f dash 1 exists or not. So right hand limit, in order to check existence of f dash 1, RHD must be equal to LHD, left. Okay, so right hand derivative equal to left hand derivative at x equal to 1. So right hand derivative at x equal to 1. So here limit h tends to 0, f of 1 plus h minus f1 by h f of 1 by h. So limit h tends to 0. Now we are putting the function a to the power sin 1 by h minus 1 this one is h. We can split the limit over here. Limit h tends to 0, e to the power 1 plus h whole to the power 10 minus 1 plus 1, and this can be written as 1 plus h whole to the power 10 minus 1, and then we will multiply this extra part h and plus 0. Okay, so ultimately we can put the value. This will come 10. In case of LHT, limit h tends to 0, f of 1 minus h, f of 1 minus of h. So here limit h tends to 0, the same way we can proceed. A to the power sin 1 by, this one will be only minus h minus 1 whole divided by minus h, and we can do the little bit of adjustment at the end like the way we did in the last part. And 1 minus h, 10 minus h plus 0, so this is 10. So left hand limit and right hand limit same, so they are equal. So 1 equal to 10 and it exists. Now coming to the second part of the question, they have asked us to find the limit value of u tends to infinity and 100 u minus u k equal to 1 to 100 f of 1 plus k by u. Okay. Now here if u becomes infinitely large, so k by u becomes arbitrarily small and finite value of k. So clearly k is a finite, where as we are interested in k equal to 1 to 100. So k is finite. Now here f of 1 plus k by u is nothing but of 1 to 1 function. So with respect to this structure, we can multiply with k by u the entire pattern, and let's see what happens. So here we have it. So limit u tends to infinity, and u k equal to 1 to 100 k into f of 1 plus k by u by k by u k by u, taking it inside. Okay. Now in the very next step, limit k tends to infinity can take it outside, and the summation will be outside. It will be relatively easier. K to 1 to 100 k, limit u tends to infinity, f of 1 plus ku and k by u. So it is simply self-evident that k equal to 1 to 100, limit u tends to infinity, f of 1. Okay, so here we can simply directly write this one is as k into minus f dash 1. This we have calculated that. So k we already know, and here we can put the value n into n plus 1 by 2. So the answer is minus 50500. Hence the answer to our third question of this pattern is dependent on this area based structure. Okay. Now this one is a fourth question. They have given S be a square formed by 4 points. Simply you can see it unit points. It's a square. Even though they haven't given this, this is easier. Let the square region R be the set of points inside S which are closer to the center than to any other side. So it's closer to the center. For example, this is the center and this is this. So we want to take the half of the distance. So for example, in this particular region, we are interested about these points rather than these points. But it is not a straight line points. There will be a parabolic structure. That is y square equal to minus 4x. So we will do it. Let me just first draw it. This is our square. Okay. So this is 1 1. This is minus 1 1. This is minus 1 minus 1, and this is 1 minus 1. So these are the 4 points. So here you can divide it like this. So this is the half of the distance. So any point in this side. Similarly here, this is the half of the distance. Any point this side is the half. This is the half. So anything which moves like this. So if we have if a circle is there, it's not useful. If any other hyperbola is not useful, so the only parabolic path will be an assumable particular area in this particular sense. So we just redraw it. So if there's a parabola, remember that in our class also I tell you about the basic formation of the 4 parabolas. It looks like a butterfly. And now these are all inverted parabolas. Now if we just reverse all these parabolas, so if this drawing goes like this, so this part will be moved in this way, and this will go by this point, okay, like this. The second one will be via this point and this. Similarly, the third point of the parabola will start from this point, and it touches this and it goes like this, and the fourth point will come and go like this. See, so this is a particular formation, and we are interested, let me use a different color, in these particular area. This is the area we are looking for. Okay, so how to find this particular area based structure? Let me just take any one point. If there are 1, 2, 3 and 4, these 4 are same. So if we take any one, we can go for the other 4. So here we just draw this portion bigger. It will be easier for you to get a grip. Okay, this one is the y. Okay, now the parabola went like this. z, this is a straight line I'm taking, 0, this is the halfway mark. Okay, if this is z, this will be 1 minus z, and here the halfway mark, like this. Really, this is 1 minus z. Okay, so maybe just n. Okay, and here the parabola is going, so this is our one thing. Okay, now this is the formation of the area, and we need to find out this area. And along with that, this area. It looks like a triangle, but it's not. This one is a straight line, this one is a straight line, this is parabolic. Okay, and here this point is 0.5. Okay, so here what we do now is, so here is z. So just by applying the Pythagoras structure, z square equal to 1 minus z square plus 1 minus z whole square, or z equal to root 2, as it is given, z as 0 less than equal to z less than equal to 1, so we can do the root over, so z equal to root 2 by root 2 plus 1. We are just rationalizing, we can write this one will be 2 minus root 2. So the coordinate of this point, now we have root 2 minus 1, root 2 minus 1. Okay, so now here we can proceed directly and we can integrate. Let this be area 1 and this be area 2. So this area 1 can be calculated from this 0 to root 2 minus 1 a1 and root a1, and the other area will be associated with this until the maximum point, means this point is half, till this. So this is 0.5, it's the area 2. So just manage to find this area, it is easy. Now we have to figure out the equation of this parabola. Let there be a straight line like this, okay, and this point may be L, okay. This is the area L. So this part will be 1 minus z. So we can take this point OL and let there be a straight line which cuts, this is also a 1, which cuts it at K1, okay, and let the coordinate of L be H comma K, that we can take. So here OL equal to LK1, and just by the Pythagorean structure we can write this is 1 minus K, because the full is K, 1 minus 2K. So replacing with xy, 1 minus 2y, so y we needed, so 1 minus x squared by 2. So the first integration we now get it as this thing, root 2, 0 to root 2 minus 1 dx. Okay, so here you can directly calculate this part. This will be 119. Similarly in the second part, which is root 2 minus 1 to half, the second integration will be like this, and next time we only have to draw it via this area to this particular distance, and we can get the equation as work over 1 minus 2x dx, which you can calculate this area as 0.02. So adding these two areas, so a1 plus a2 is now 0.21. and into 4, so 0.84 unit square is the total area of the portion which is closer to this. So coming back to the question, so the find out the area of the region R is 0.84. This is not the exact answer, in root over it is coming. I have given it in the examination. If you have done it, for example, like root 2 minus 1 in that way also, you will get full marks. The rest of the solutions are will be given to the students of our classes only, like question 5, 6, 7, 8 and the MCQs as well. For that you can see the links and description below and my phone numbers and WhatsApp. So if you want to take the rest of the part and our classes and online, you have to subscribe the channel and you then call us. Our executive will help you with the structure. Hope to see you to crack the forthcoming ISI examination with flying colors. Thank you.